Hey, 6th grade. This is lesson 2.2, compare rational numbers on a number line. I can compare positive and negative rational numbers using a number line. So this has changed from integers to rational numbers. That just means that there's fractions and decimals involved. Step it out. You can compare fractions by graphing them on a number line. Mrs. Smith and Mr. Jones each have 30 students in their class. If Mrs. Smith corrected 3/4 of last week's math assignments and Mr. Jones corrected 5/8 of last week's science assignments, which teacher corrected the greater portion of the assignments? As what marks on the number line would you need to graph 3/4 and 5/8? Well, if I were going to do 3/4 and 5/8, I would need 0 and 1, because somewhere in between that are my points. Okay, and then it says graph the fractions on the number line. Now here's the deal, guys. They're obviously counting 1, 2, 3, 4, 5, 6, 7, 8 spaces. That means that they are counting by eighths. So anytime you're not sure and it's fractions, you can count like that and it'll tell you. So we can see that at 1, 2, 3, 4, it's 1/2, 4/8. So 4/8 simplifies to 1/2, okay? So we can very easily, let me erase this real fast. So we can very easily write on here the 5/8 because it's already an 8. So 1, 2, 3, 4, fifth mark over is 5/8. However, we have 3/4. If our number line is counting by eighths, our fractions need to be converted to eighths to put them on the number line. So 4 times what is 8? Times 2. 3 times 2 is 6. So 3/4 is the same as 6/8. So then we would put 6/8 right there, okay? So in order to graph fractions on a number line, you have to have the same denominator as the number line has, otherwise you're just guessing. It's much easier just to change the denominators to be the same thing. All right, it says, note the locations of the numbers. 3/4 is to the blank of 5/8. Remember that this one was 3/4, okay? 3/4 is to the right of 5/8 on the number line. So 3/4 is greater than 5/8. Write an inequality statement. Remember this word. This word inequality is not going anywhere. We have to learn that word. That's where we use the greater than or less than. That's why they had us decide which one was bigger. So we know 3/4 is greater, then we can write 3/4 is greater than 5/8. So Mrs. Smith corrected, let's see, Mrs. Smith did the 3/4 and Mr. Jones did the 5/8. So Mrs. Smith corrected more than Mr. Jones. All right, so to do that, we had the same denominator. And then we use the number line, right? And remember, as you go to the right, they get bigger. All right, E says, use the number line to help you write an inequality comparing negative 5/8 and negative 3/4. So now, let's use that number line up here. Okay, so over here I can see, here's 1/2, and then 5/8, and then 6/8, or 3/4. So it's going to be the same on the other side. I have negative 1/2, then negative 5/8, then negative 6/8, or 3/4. Remember, they're the same, 6/8 and 3/4. Okay, so it says write an inequality comparing those numbers. So let's go ahead and write negative 5/8 and negative 3/4. All right, so then in between, I need to figure out which one's bigger. So look at them on the number line. I have negative 5/8 and negative 6/8. Which one is further to the right? The 5/8. So negative 5/8 is greater than negative 3/4. All right, so you can also use decimals on a number line, and any number that you put on the number line, you're actually comparing it. It doesn't matter if it's fractions, decimals, or whole numbers. All right, the record low temperatures for 5 cities are Ashton, negative 0.6 degrees, Bares, negative 1.7 degrees, Carl, 0.7 degrees, Davison, 0.4 degrees, and Edgeville, negative 1.5 degrees. Graph the temperatures on the number line and label each with the first letter of the city's name. Well, so when I look at these, I see that all of the decimals are to the 10th place. So if you remember, this is the ones place. Well, and this one is the tenths. Okay, and there are 10 of them before you get to 1. So let's see if that's how they counted on their number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it is. So because that's what they're counting by on their number line, we can count that when we plot them. So Ashton is negative 0.6. So we know negative is to the left of 0 and it's 0.6. So we just have to count 6 little lines. 1, 2, 3, 4, 5, 6. So that's Ashton. Okay, so then let's see. Bares is negative 1.7. So here's 1. I'm going to go 7 past it. 1, 2, 3, 4, 5, 6, 7. Carl is 0.7, so that's going to be 7 dashes from 0. 1, 2, 3, 4, 5, 6, 7. Davison is 0.4. 1, 2, 3, 4. Edgeville is negative 1.5. So go to the negative 1 and then 5 more. 1, 2, 3, 4, 5. Okay, that should be on that tick mark there. Okay, so we labeled them. Now A says, know the locations of the numbers of Bares and Edgeville. Okay, so Bares, let's see here, and Edgeville, right here, these two. Negative 1.7 is to the left or the right of negative 0.5. Negative 0.7 is the Bares, B, so it's to the left. So Bares' low temperature is colder or warmer? It's colder because it's further to the left. It's further from 0 bar. Okay. Then we're going to complete the inequalities. 1.7 and negative 1.5. You can use your number line. Which one's further from 0? The negative 1.7, and because it's negative and further from 0, it's colder. So we would use the less than sign. What about negative 1.5 and negative 1.7? Same numbers. Which one was further from 0? So negative 1.5 was greater than negative 1.7. All right, so that is today's lesson. Thank you for listening and following along.